take some notes on the periodic table because that's one of the most important parts of our lessons in chemistry. Yes. Yeah, you can borrow that pencil there, or there's a few on the left. So let's title this the periodic table. And let's say patterns, because there are things on our periodic table that are always ongoing. Like the numbers will always go from left to right, getting bigger and getting bigger from top to bottom. Also, there are numbers that are not on this chart, but are going to be increasing as you go certain directions as well. So let's go over the different kinds of numbers that the periodic table has. So the different types of numbers the periodic table has are ... Now the first type is atomic number. And we've taken notes on this before. Who remembers what atomic number means? It's the number of protons. Good. The number of protons in an atom. So if I showed you a box from a periodic table and one of them was, let's say, gold, AU. So everyone find gold on your periodic table. Is it blurry? And let's write the two numbers that are there. There's one on top and there's one on the bottom. And there's gold. Now, which is the atomic number? Is it the number on top or bottom? It's the number on top, the whole number. Now, an easy way to remember that this is atomic number is that there's no decimal. Never has a decimal. So what would be the atomic number of silver? Silver is Ag, one above it. What is silver's atomic number? 47. Good. And then from this row, what is the atomic number of copper? Cu. This row here. 29. Not the decimal, because you can never have a decimal of a proton. Good. Let's go to the next number. Another type of number is atomic mass. And atomic mass is two things added together to make something. And it's also an average. The atomic mass is something plus something else. Let's make it equal. What two items make up atomic mass? And there's only 3 total in an atom. What are they? Protons and neutrons. Protons and neutrons make atomic mass. Now, sometimes when you add numbers together and you divide them out, you won't get a whole number. You won't get a perfect digit. You'll get decimals. And that's why on the periodic table you'll find that there are decimals with the numbers. So let's look at 3 others. Let's look at neon. You've heard of neon lights. Find Ne. That box, draw that box. And let's write everything that's there. 10, the name, and atomic mass. And which is going to be the atomic mass, 10 or 20? 20. The atomic mass will have a decimal. It's also the average mass of the element in the world. So we find neon atoms in several parts of the world. Usually it comes from the sky. And we'll never find it to be perfectly 20. Some will be 21, some will be 19, some will be 19.99, some will be 20.99. So that whenever we add those different kinds of atoms together, we'll find that it's around 20.18. So average masses will have decimal because it is the average atomic mass, the average atom mass. Right? If we added up all the students at Southgate High School and found the average, that'd be an interesting survey to do, find out how much everyone weighs, even though our weight is changing. What do you think would be a good number? Like 100 what? How many pounds do you think? 150? Sure. Maybe for like guys, and then for girls would be average what? Like 110, right? Okay, let's write those down. Average mass for Southgate High School boys is 150, and let's say like 0.5. Okay, let's somewhere in between 150 and 151, 0.5 pounds. Okay, notice how it has a decimal just like our atomic mass. And then average mass for Southgate High School girls, it was 100, what do you think?
20.
120, let's say 0.2. Okay, 120.2 pounds. Just like atomic mass, it has decimals. Another number that the periodic table uses are group numbers. Group numbers. Now, group numbers are located at the top of the periodic table. So take a look at the top of your periodic table and notice how you have these numbers. Now there's two sets. It's the group number is the number with the letter. So it might be A or it might be B. It's at the periodic table with letter A or letter B. Let's write 1A, 2A, and then let's write 1B through 8B. Okay, so it's about 10 different groups. Are they metals, non-metals, or metalloids? Who remembers that? Are metals on the left side, the middle, or on the right side? Left and middle. Good. Because look on your table right now. You see the 1A, 2A, and all the B's? Those are all metals. Transition metals, alkaline earth. Okay. So let's label that. Are all metals. Put that in caps. And there are a few exceptions, but generally it's going to be those groups. And 3A through 6A, 3A through 6A, staircase, notice how there's a staircase, are mostly, what are those called? Metalloids. Mostly metalloids, that's what I was going for. And let's say 4A through 8A non-staircase elements are called what? Everything that's not touching this dark line but is 4A through 8A, what are those called? They're called non-metals. And a student left behind one of their periodic tables. I guess I'll post this online. It's nice when it's all done for you. So we did this in my class. Everything that's in blue is groups 1A through 8B, so all of these. And everything touching the staircase from 3A to 6A are green and are non-metals, metalloids, and then the orange from 4A to 8A are non-metals, just like we've covered. So that's a great reference to look at. It's also the same in your textbook in the back, and it's going to be on our assignment today. We're going to go for 4 more minutes on some notes. Turn the page. And let's cover electronegativity. So another number that is on your table but it's not there, right? It doesn't say electronegativity on your periodic table, right? Is electronegativity. Now, what is electronegativity? Does it use the electron, proton, or neutron? What's the key word here? Electron. So it's the electron, let's say attraction, the electron attraction atoms have on the periodic table. Now these numbers are from 0 to like 3. It's very, very short range of electronegativity. Now we don't need to memorize it because there's a nice trend. Draw yourself a periodic table, nice miniature version. Metals, metalloids, nonmetals. And you need to know which way does electronegativity increase. And after we take some notes, I'm going to have you stand up and show me which way you guys get taller, which ways you guys get shorter. Because the periodic table also has trends where it gets larger and smaller if you go from left to right. Electronegativity. Here's your left side. Here's your right side. Now, if you are standing here, let's say you had a giant periodic table and you're looking at it from the bottom right-hand corner, and you're looking at it this way. Go ahead and draw a little person and then write your name. You could say Mr. Lim. You should have your name there. If you have long hair, you can put long hair. Put glasses on mine. Now, what happens to electronegativity if you're looking from right to left, right? If you're going this way, electronegativity will decrease. You have to know that. It decreases. Decreases. It's a pattern. So up here in this corner, it's going to be approximately like 2, okay, maybe even 1.5. But as we keep going down this table, looking at element to element, like going from polonium to bismuth to lead to thallium to Hg, it'll probably be down to 0.3 francium. Very, very low. So let's even make a little example for ourselves. 1.2, 1.1. Let's say it's 0.5, 0.4. It just gets lower and lower and lower. Decreases. But what happens when you look up? It increases. Good. So as you look up on the periodic table, it'll increase. So what's a big number bigger than 1.5? Sure. We don't go up to 3 yet. Let's say 3 is at the top, very, very electronegative, and in between is like 1, like 1.7, and it's like 2's up here, 1.6 is down there. So that's electronegativity and the numbers that come with the periodic table. All right.